Thank you. Thanks. So this talk is we'll see how it goes. It's a fun exercise where I will try to write your own Excel 365 in 45 minutes, actually. So that's stepping up the challenge a bit. And I'm going to start from pretty much from scratch. There's very little that I have already in my code. So I think that's enough for the introduction. We only have 45 minutes, so let's get started. I should also say now at the University of Kent, and I still do various things with F# works. So if you're interested in helping your company convince everyone that they should use F#, then we can help. So I'm going to scroll down here and make this a little smaller. And I have a setup here where I do have Fable running in the background, and I'm using a very small version of Elmish. It's not actually the sort of official Elmish library, it's just my own little variation on that, because that's super simple, it's just 10 lines of code or so. And this is running already, so here's the browser where you can see my completed application, which does absolutely nothing at the moment. And we're going to start. So we want to write Excel, right? As an F# programmer, whenever I want to write something, I'll start by thinking, what's the domain? So what we have in Excel, we have positions for our cells, which are character and an int. So this is going to be how I'll represent offsets in my spreadsheet, and we're going to use, and I'll say more about this, we're going to use the Elm-style architecture where we will have some state of the application. So what's the state of an Excel spreadsheet? Where we have a list of columns. They're the characters. So this is a list of all the columns that we have. We have a list of rows, and this is an int list. When you click on one, it becomes active, but there doesn't have to be one. And as you can see, I can't even type syntax correctly. So active is position, but it can be optional because you might not have selected a cell. And we have all the cells. So we're not going to store like a 2D array, but rather a map that maps position to what's typed in there. So that's my state. That's a good start. And we can create an initial state. Initial, where actually, given that this is 45 minutes, this is not very creative part, so I'll cheat and put it here. So initial state, we have rows from 1 to 15, we have columns from A to K, active is none, and we have no values in our spreadsheet. So that's a good start. We should probably do something so that we actually see something on the screen. And the way this is going to work is that my little Elmish, mini Elmish library defines a function called app that takes the ID, the initial state, and it takes a render function and update function. Now, if you're not familiar with these, I'll say what they do later on. Our initial implementation of update is just returning state and render. And again, I'll say what this exactly does. But it takes a state and it has to render the page. So, and I'm using this little library because I was too lazy to type out all the different HTML element names. I'm just using question mark, where you say H question mark and then give it the element name that you want. And if we do this, then our page should say, hello, open F#. All right, so it did update in the back. Fable recompiled the code, and we see new thing. So what do we need to do now? Well, we should render the nice Excel grid. So I'm going to start with that, and we're going to create a table. The table is going to have one header. So to do this, I need to do header. What's in my header? I need one dummy cell at the beginning. So this is going to be empty, the sort of left upper corner. And then we iterate for all the columns. And here, I'm going to just use the columns I have in my state. So if you add more, it's going to be fine. And for every single one, we are going to do header with text being the actual name of the column. So that should be the first row. And now we need to generate all the rows. So I'm going to go over all the rows. And for every single one, we're going to create one tr. And again, we need the first one, which is special. So this is th with just text being the row, the number. And then we need to iterate over all the columns again. And for every column, we will actually call some render cell function, which will take a couple of things. So render cell will take the trigger parameter, which I'll explain. It will take the position. So this is the letter first. That's a col, and then row, and all the state. And now I just need to define this. So I'm going to say let render cell. And initially, just to see how far we've got, we'll just render empty cell. All right. So this is what we've got so far. It looks excellent, but it doesn't actually do anything. So maybe we have some more work to do. I don't like the scrolling, so I'll just tweak it a little bit and decrease this to 12. And I should update, and looks nice. I think one thing I really like about what I've done so far is that as I'm typing it, I can test it immediately. So I'm sort of progressively building up, but I know that what I wrote is actually working. So that's good to know. And what I'm using here as I'm doing this is the overall architecture is this nice Elm style thing that in Fable Elmish is doing, in Xamarin the library that Don was talking about yesterday is doing it. And the idea is really simple. You just have state, you have events. Given a state, you can render a page. And when something happens, given a state and an event, we can calculate new state. So it's really, really simple, nice functional idea. And what makes it work is that when you render new HTML, there's a virtual DOM library that will calculate diff between what you have and what you had before, and just apply the changes. So it's not like replacing the whole page. That's the key trick. And the renderer also gets this function which should be called, this is actually wrong, it should be like this. It gets a function that it can call to trigger an event. So I can attach an event handler and say trigger an event, and it will then cause all the redrawing. So let's do something more with this. I'm going back to this size. So what do we need to do? We need to do the rendering, and our current render cell is just very dumb. And I'll have two different rendering functions, so I'm going to copy this here. I have render editor, which is the one that creates the input for the selected one, and I have render view, which will just render the view. Now, how do we decide which one to call? So if the current state, if active is this position, then we are going to call render editor. And otherwise, we are going to call render view. It gets the same things. And what's the value? So the value should be whatever is in this position. So we are going to look at cells, and I'm going to use try find here to find this position in the cell. Now this is option because it might not actually be there, and this is something we'll have to work with later, but for now I can just do default arg value empty string. So this should do some rendering. I'm not actually going to save this and show you because we have no way of entering text yet. So that's something we probably need to fix. The first thing we might want to do is to say when you click on a view, so the way I'm specifying the arguments here is that this funny operator with bang means attach an event handler. So when onClick happens here, should I call, I think this might need to be click rather than onClick. We'll see later on. Here we want to trigger an event. What event? Well, that's the thing we need to go back and define. So what are our events? What can happen? There's two things that can happen. And I should make sure I name them the way I think I named them. So start edit of position is an event that happens when you click on a cell, and update value of position and string is when you change a value in a cell. So here, when you click, we want to trigger start edit. And this is getting closer to actually being able to select thing. The one thing that we haven't done yet is the update function. So when the event happens, we need to change the active cell. And this is what happens in this update function right here, where we get state, we get the current event, and we need to produce new state. So I'm going to use pattern matching here and say, when I get start edit on a position, I'll return a new state, which is the same as before, except that the active cell is this one. Now, I get a green squiggly because I'm not handling the other event, but I'm not triggering it yet, so I'll ignore that. So can I click on things? I can't, and that's a sign that I should have used click rather than onClick. All right. Can I do it now? Did it actually reload? Ahaha. It failed to compile because I'm doing something wrong on line 71. And my update has a wrong type. And this is because, well, let's have a look at update. What does update do? Update takes state, event produces a new state. What should it take? Render. I think my trigger function is wrong. Let's see. What happened to my trigger function? My trigger function here is position. Well, I was expecting that my trigger function would just be event to unit. And start edit takes a position, see? So here, what I want to do is start edit of position. And this should do it. Yes, that's good. And now, I still can't click anywhere. Can any? Ah, yes. So is onClick the actual thing to do? Aha, thank you. Yay, we can. So I can even type in things, but they'll disappear. So it's getting better. It's not quite there yet, but we've made some progress. I guess you could see one useful thing when doing F# development, which is that as I got it terribly wrong, I added a type annotation for things that I knew are the way. I added an annotation that says what I think it should be, and then the compiler was actually able to tell me where I'm doing a wrong thing. So that's one really useful pattern. And the on-click thing, that's solved in proper LMesh because they have a type for it. So that's good. Now what we need to do, we need to store the values, and this is a bit where I'm going to cheat again because it's a lot of typing and it's not very nice typing. So if you're in the editor, in the input, the way we do this is that whenever any change happens, whenever the user puts in any letter, the onInput event gets triggered, and we will trigger an update value event where we save the current position, and this bit of code actually extracts the value from the input element. So we get the text, we save it, and if we implement the update function, and we get new value, then it should work. So we are going to create new cells, which is just adding to our map for this position, this value, using our current cells. And then we are going to return state with cells being new cells. So now, if it reloads, I can say 1, 2, 3. It should stay there. I can say 4, 5, 6. It stays there. I can say 1 plus 2, and it stays there. So we can now edit the spreadsheet, and it doesn't actually evaluate things yet. So that's going to be the next step. And to do this, I'm going to need to write a parser. And there's lots of ways of doing it. I have a very simple parser combinate library, so that's one of the things that I'm not actually showing you. It's not too long. It defines a type parser, and parser is something that takes a list of characters or a string, and it can either produce none, meaning I can't parse this, or it can produce some containing a parsed value and the rest of the string. So it reads the first few characters as far as it can go, parses something, and then it says the rest I don't understand. And we have two functions for composing parsers. The one with the bar means run this parser or this parser, and whichever, if the first one works, return the first result. If the second one works, return the second result. So they have to have the same type. And I have the star thing, which says parse the first thing, then parse the second thing, and then return both of them. So that's all we will need for parsers. And to write parsers, I'll just copy my hints to the right place. So that's my parsers. What are we going to produce as a result of the parsing? That's one more thing we need to figure out. So the result of the parsing will be an expression. And what is an expression? What can you actually type in a spreadsheet? You can say number. So if I have number, it's just a number. And we are going to do a very simple thing. So we'll just have binary, where there's a character representing the operation, like plus, and there's expression on the left, expression on the right. So you can nest them as well. And now we want to write parser. So an operator is going to be plus, minus, times, or divide. And the way you parse them is we say char or this. So an operator, and I need equals here. Operator can be either of these, and this gives me a parser that parses a character, but only the allowed ones. And I'm going to need a number. And there's a built-in parser for integer, which parses an int. But I actually want to build a parser that produces these extra values. So the parser library also defines a map function where I can say map the parser for ints to a function number to get a parser of expressions. So I've got parser of expressions, and to get a binary, we'll start simple. We'll just say it's a number, followed by an operator, followed by another number. And this creates a parser for expr, char, and expr. So we're going to need another map here to say left operator right. And from these, we can produce binary by saying binary L op R. OK, so we've got parser for numbers, parser for binaries. They have the same type. So I can say equation is either binary or a number. So this is a very simple parser. It doesn't do the recursion yet. We'll add that later. And we want to see how it works. So I'm going to go to my rendering here. And what I have to do is, if I get the value, so I'll have to move things around a little bit. Because if I don't have a value, then I just want to say it's empty. But if I do actually have a value, then I want to parse it. So if I don't have a value, we're just going to render an empty cell. But if I do have a value, then what I'm going to do is I'll run the parser, and there's a run function for it. And run takes an input, takes a parser, so that's equation, and an input, that's my value, and produces parsed result, which is an option of expression. And we're just going to be nasty here and say convert whatever we get to string so that we can see it. So let's see what happens now. If I say 1, 2, 3, I get number 1, 2, 3. Fable nicely formats the fstar value. If I say 1 plus 2, it says binary of number 1 plus number 2. So it does seem to be working well. That's a good start. And what we need to do next is that we actually need to evaluate these things. So this was all the parsing. I'm going to make this a bit fancier in a next step by supporting the recursion. But again, the sort of important thing at this point is that we're using a nice discriminated union type to model what we are working with. So just like we have types for the whole spreadsheet, we now have a type that models the expressions. And we started with number and binary. We're also going to add reference to say, like A2 plus 1, for example. So we'll need to add references here. But it's a nice type that defines what the expressions are, what the equations are. And when you're writing this, you have to think about what we actually want to support. So I'll have a basic Excel with just these, but you could add more. The other nice thing is that a lot of code that we have to write sort of revolves around this type. So the parser was written to actually produce these values. Now we have to write an evaluator which will pattern match on these and do some stuff with it. So we have to write an evaluator. Where do we put it? Evaluator is interesting because it's going to be a recursive function. It will take the expression, it will pattern match on the expression, and if it's a number n, then this is the easy case. We just return the number. That wasn't very hard, was it? If we have binary, then this is more fun because the left and right, they're just strings, so we need to, well, they're just expressions, but they're not the results. So we have to first recursively evaluate those. And I'm going to say evaluate L, evaluate R. So we recursively evaluate both of the sub-expressions. We don't have parser for it yet, but we will add that soon. And now we need to run the operator. So this is another part of my talk where I will attempt to use multiple cursors. So what we want to do here is, or what I'm trying to do here, is to produce a dictionary which, for a character, gives me the right numerical operator from F#. So if my key is minus in quotes, and my value is the actual function. So this is a dictionary from characters to functions, and I'm going to be a little sloppy on error handling, but it's actually fine because the parser will only allow these characters. So I'm going to index into this to get my function and call it with the left and right value. So that's my evaluator. And should we try running it? I guess we should. So if we go back to our rendering function, when we parse the function, it's an extra option. So what I'm going to do is say option.map, and we get the expr, and we're going to call evaluate on expr. This will give us an int, so I'm going to convert this to string. And this is what we actually want to display. Okay. So if I say 1, 2, 3, that should still work. But if I say 39 plus 3, we get 42. Haha. Now I'm going to cheat and make it a lot more impressive by fixing my parser. So this is my third snippet I'm going to use, third and last one, where I inserted all this code. And I delete this. So what this does is that it doesn't fit on the screen. What it does otherwise, so there's one difficult thing about this, which is that the expressions have to be recursive, because you can have an expression inside an expression. When you say 1 plus 3 times 7, it's a nested thing. To do this, I have this slot operator, which gives me a parser for expressions, but it gives me also a setter that I can then use to put, it gives me a parser that I can compose with other things. So you can see on the next line, I'm actually using it. But then it gives me the expression setter, which I can use later on to actually set what the parser is. So I'm not using recursive values here. I just have a mutable parser that I mutate. And I have a formula where I have equation. I also inserted all these any spaces so that you can have spaces. An equation is either a number, that's just 1, 2, 3, or a formula which starts with equals and then has an expression. And an expression is this recursive parser, which can be either binary, so expression followed by operator followed by expression, or a term. And term is either a number or a bracketed thing with an opening bracket, expression, and closing bracket. So the summary is, if I save this, I should now be able to say 42, or I should be able to say equals 5 times 4 plus 2, and yeah, my numbers are wrong. It needs to be 10 times 4. So I can write fairly simple equations. It will evaluate them. It works. Now, what we need to add next is we need to add the references. So this is going to be the more interesting part. I think I've got everything else. Yeah. So references. Well, what we're going to do first is we're going to modify our expression and add reference. And when you're using this, you have reference to some other position. So that's reference of position. We need to add a parser for it. So aside from binary and term, well, actually, I have to add this here. So a term can be number or a bracketed thing or a reference. And a reference is a letter followed by a number or followed by an integer. So this is type char and int. And that actually, char and int is the right type for the reference constructor, which takes position. So this way we wrap the parsed string, the letter and number into an expression, which is a reference. So we've got a parser. We need to fix our evaluator, as the fsharp compiler helpfully tells me. So if we reference a position, what do we do? Now this is a bit where it gets a bit tricky, because we don't really have the state here yet. So I'll have to modify my evaluator to take cells as well. And this I wanted to put here. So cells is going to be all the cell values, and I'll be sloppy initially and fix this later. So we'll just look up into the map, assuming it's there. Who writes bad Excel spreadsheets, right? So this is the input. Now we'll have to parse it. So we're going to say run equation on input. This is my expression. Who writes bad expressions? We're just going to call expr.value. I get a lot of blame for using this. This time I'm actually going to remove it later. And then we say evaluate this parsed expression. So if the user actually writes a valid reference, this might work. And there's one more red squiggly here, because we now have to call evaluate and give it all the cells. So I'm going to do that. And if we save things now, if I say, so this is the bit where it's actually useful to open the console and see in what ways it fails. So if I say 1, it's good. If I say 2, it's good. If I say equals b3 times 7, it's 14. Ooh. So good so far. If I say d4 times 7, what happened? I actually didn't want to do this. I wanted to say d3. But I did write d4, and I created a recursive reference. And I got a Stack Overflow exception here. The other bad things I can do is I can say HHH, and then it's null, because that's what we get for none. Or I can say C4 plus 1. No, C3. I get option has no value. So I have a spreadsheet, but it assumes that the user is very well behaved. So maybe that's not the ideal place where we want to end. And I'm going to do one more thing with this spreadsheet, and I'll use the railway-oriented programming idea in a very, very basic, simple version to propagate failures or handle failures. So my implementation, again, it's not using a bigger library, but in many cases is actually good enough for doing what you need to do. So my evaluator and everything that can fail will now return option, which is either none or some. And I'm going to use the map and bind functions on options to propagate errors. So my map says, if I've got an option and a function that can do stuff with it but doesn't fail, I get an option with the result. Bind says, if I've got an option of t and a function that takes t and can produce result or can fail, I'm going to get just one option, which is either the value of the right thing or a none if any of the two are missing. How are we going to do this? I'm going to go back to my evaluator and change it to return option. So in case of number, this is not going to fail. We just return some. And now I basically just have to go through my code and fix all my bugs. So what do you need to do differently? reference, so there's plenty of space for failure here. It might be a reference to a wrong cell. So this can fail, and we will wrap it in bind. The parsing can fail, so we're going to wrap that in another bind. And finally, the new version of the evaluator can fail as well, so we're just going to use bind. And if either of the two fail, then we're going to fail. Binary, we have to do a similar edit here because both of these can now fail. So what we're going to do is to say option.bind and left value. Now the second one, here we can just use map because the actual calculation here cannot fail. So we wrap it in bind and map, and I suspect I forgot a bracket somewhere because it's complaining here. Did I forget a bracket? I must have forgotten a bracket. If I remove this thing, then it's fine. So there must be, well, no. I'm not going to say what was the reason. There's a bug in my editor. Now we're all good, and there's one more thing where we need to do a little bit of work, which is when we actually call the evaluate function here. So after we run the parser, we want to do option.bind, and we get the expression, and then we're going to call evaluator, and if this succeeds, we're going to turn this into a string, and this I now call expr. So now we have the proper option handling here as well, and we don't need this part. I actually want to do one more change, which is that when there's an error, I want to display this as a red warning. So my res is now an option, and I'm going to modify the render view function so that it takes an option, and if it's none, it displays it in red. So in render view, I'm going to say if value is none, then background, no, color red, else nothing. And here I'm going to say default arg, and the default arg is going to be #, which makes it look very Excel-y. All right. So if we say 1, 2, 3, that's good. If I say equals high plus 4, it's an error. This is not a PHP, it's an error. If I say D5 plus 1, that's an error. But if I go back and actually say maybe 2 plus 3, then it magically starts working everywhere. So you can see that my Excel actually has a nice live updating feature while you're editing the formula. So this seems to be working. There's still some fun we can do. If we say F7, we still get a Stack Overflow exception because we're not handling the recursion correctly. And I thought if I'm doing a talk about writing Excel in F#, I should at least in one way make it better than what the actual Excel implementation does. So we're going to handle Stack Overflows in a nice, clever way. What Excel does is that it just calls evaluate some number of times, like I think 100. And if it doesn't finish, then it says, well, I guess it's a recursive reference. I'm not going to give you a value. What we're going to do is that we're going to keep track of the cells that we visited as we were evaluating, and if we get to a reference to a cell that we've evaluated already as part of this expression, then we're going to stop. And the way to do it is that in my evaluate function, I'm going to keep track of visited cells, and I have to pass it around here and here. And when I'm visiting a reference, I'll say set, this is going to be a set. We're going to add this position to my visited cells. And we're going to add one more case, which says reference pos when the set of visited cells contains the pos, and then we just return none. And I need to start by having empty set here and save it. So now, if this reloads and I say 1, and then I say D3, and then I say maybe D4 plus D3. Yeah, that's still correct. I'm doing Fibonacci numbers, see? But I wanted to do plus D5. And that's an error, and we get no Stack Overflow exception because we're handling this properly. All right, so I think this is all I wanted to do. We have an Excel spreadsheet that actually does quite a lot of things, and I still have 6 minutes, so I'll do 2 things. One is that I want to clean this up a bit, just to show you what we've actually done in the talk. I'm also going to delete all my unnecessary comments now. So what have we got here? We've got our domain model, which defines the position, state, and event. And somewhere I have an expression as well. I should put that in my domain model too. So my domain model talks about what is the state of the spreadsheet, what are the events that can happen, and what are the expressions that you can put in the cell. So this is really telling you quite a lot about the application we've written. And the rest is just an exercise left for the reader, right? Now, I'm going to move the initial state somewhere to the end to keep it a bit cleaner. And we've got domain model, then we've got some code to do the parsing. So this is all this stuff here, which implements the parser for all the different things you can do. We've got evaluator, which, given an expression, it properly evaluates this, handles errors, and handles recursive references. And then we've got the rendering code for editor, view, cell, and the whole page. And then we've got the update function. We've got the update function, which is handling events. So if something happens, we will update our state. And then at the very end, I added the initial state, which is what we start with, and calling of the Elmish library to actually do the work. So if I count the numbers here, it's 129 lines. It's not quite just 100 lines, sadly, but if you had bigger screen, you could probably make it 100 lines. This is also, I think, the step where if you're actually taking this further, now that we've neatly organized it, you could split it into multiple different files. So this is a domain file. This is a file that defines the parsers. This is one of the multiple files that you would probably have to do some transformations or operations over the domain. And this is the user interface. And pretty much every single thing in this file is a function that takes some input, produces some output. So it's going to be really easy to test it. because you just say, given this input, does it produce this output? And that applies not just to my calculations, but also to everything in my user interface, because I can check if the renderer, given a certain state, produces an HTML DOM tree containing certain values. Now, there's only one thing I haven't done in this talk to make it a real Excel, which is the way my implementation works is that during the rendering, it will actually call the evaluator to evaluate everything. And in a sort of bigger Excel in a proper Excel implementation, the way this is usually done is that you have some dependency graph where, for example, here, if I edit A1, it will know that it has to recalculate B3, but it will not recalculate any other cell. And that's something you could do. In this case, it would just be a matter of adding another operation that works over my states, but you have to do a few more changes and represent the state as something like this, where the cell has a value, which is what it evaluated to, but it has some sort of notification that you can subscribe to detect when the value has changed. And the one last thing I wanted to say is that when people sort of see someone doing live coding with F#, the usual reaction is something like, well, this is really nice that you managed to do this in 45 minutes, but is this really what F# programming looks like in the real world? And my answer is actually yes. In the real world, it takes me a bit longer because when I'm doing it for the first time, I don't know what to write, but the steps are actually pretty much the same. When I'm doing something, I always start by having a simple sort of skeleton application where I can fill things, add more features as I go, and a lot of the initial development and figuring out how to do things is in just one file. And at the point where I'm now, I would split it into multiple files and sort of do more work. But this actually is really how I work when I use F# to write applications. So that's it. Thank you for coming. The summary is Elm-style user interfaces with Fable are great because they give you this really nice model for doing UIs. Compositional functional programming spans across multiple things like defining the domain model, but also writing the parsers. That's been working here perfectly. And finally, types are great for domain modeling and for handling errors, and they helped me in a number of places as I was doing this to actually figure out when I make a change, what else do I need to update. So types are great, and that's the end. Thanks. And I'll be around for the rest of the day, so if anyone wants to chat or have a look at anything in the code again, feel free to find me somewhere and we can talk more. Thanks.